Hi everyone, my name is Bhramar Mukherjee. I'm a professor of biostatistics at the University of Michigan School of Public Health, but currently spending my sabbatical as a visiting BiFellow at Churchill College, Cambridge University. We are at Churchill College this morning, and I have the honor of having a conversation with two of my mentors here. Two incredible statisticians with their illustrious career spanning over more than 40 years each. Sir David Spiegelhalter and Professor Sylvia Richardson. David and Sylvia have made pioneering contributions to statistics, but also have taken distinguished leadership roles, have actively engaged in public communication, policy work. Together, they co-chaired the COVID-19 task force of the Royal Statistical Society, a professional organization they have both been presidents of. Along with being fantastic statisticians, David and Sylvia are also inspiring human beings and role models, and I have come to appreciate that during my sabbatical even more. It should be a statistical treat for our audience to listen to these two brilliant minds. So without further ado, I'll jump into my questions. Are you ready? A written version of this conversation is expected to be published in the conversation section of the journal Statistical Science. So let us go to the very beginning. How did you end up in statistics? David?
Oh, me? Yes. Okay. Yeah, I started off doing maths at school, of course, and then got into maths at university. And I liked the pure, never liked the applied at all. But I liked the pure. But frankly, to be honest, by about middle of the second year, it got too difficult. It was very advanced and I enjoyed it, but I just was struggling, I think. And then I was really fortunate enough to have an inspiring mentor at that point who was incredibly enthusiastic about statistics. And so I moved into statistics. Now, I didn't like stats at first either. The very first lecture was just proof of the Neyman-Pearson lemma. I had no idea why, what's this about? It was complete. So I nearly gave that up as well. But fortunately stuck to it and have always enjoyed it ever since. I was really pleased I went into that, and it's been a great career choice.
And what about you, Sylvia?
Well, it was in a very much a serendipitous way, because I met my husband in Paris in 1972 while I was finishing a math degree, which had no statistics, just one module in probability. And then we moved to the UK, and then I registered for a master in statistics and stochastic processes at Nottingham. But then I did my PhD in ergodic theory, so still I wasn't attracted by statistics at that time. And then when I was thinking of making contacts back in France, I had an encounter with the head of an epidemiology unit, who suggested that there was a problem in spatial statistics they were struggling with, and could I have a look at it? And that really spurred my journey into spatial statistics, and then through lots of collaborations with epidemiologists into biostatistics. But I say serendipitous because I got in touch with this person just because a mathematician, a probabilist that I knew, a French one, was sitting next to him in a committee, and they happened to chat. And then, he just said, "Well, why don't you talk to Philippe Lazare?" And so, I think otherwise I would still be doing something else, probably. This is, so I think it's important to adapt and to jump on opportunities somehow. And when you meet really good people who are, enthusiastic and trust you, then that's the way to go.
Yeah. Absolutely.
Yeah. Always being open to possibilities, and how much of our life is just random coincidences.
So it's really I think it's a random walk or a Markov process, but definitely no more memory, no long-term memory.
Yeah.
So over your career, you have seen the field of statistics, biostatistics, in particular Bayesian biostatistics, evolve and change. What do you think are the most significant opportunities and challenges for us right now?
Yes, I mean, the field changed because the scientific questions have changed, and by the field, it's fed by questions from public health, epidemiology to clinical medicine, biology, genetics, and so on. So it's really a broad field. And also by the availability of data to answer scientific questions that all the scientists in this field, are evolving to ask. And I think the field has been pushed by changing the nature of the data structure. We're not in IID situation. We've got dependent data in space, in time, networks, and so on in biology. Also recognition that the data is imperfect. It's full of missingness. You don't know how it was selected. You don't know, measurement error and so on. So recognizing the imperfect nature of the data. And then the fact that to answer a question, you need to put data together. So really data synthesis has been a big driver of evolution. And so, and then finally, the advent of the very large P frame, the large P problem with all the DNA, the genetic data which came online. And now the large N framework. So basically statistics and biostatistics has evolved with all these questions. But for Bayesian, I think, and David can speak, of course, very much about that. It's the unifying framework of Bayesian hierarchical model, which has been really a key and all the associated algorithm for us in biostatistics to be able to tackle a lot of problems and develop the computational tool and do realistic modeling, which really kind of makes sense. And then the community, that started in the 90s, the community joined in and showed that, Bayesian statistics could tackle an immense variety of problems and get expertise in how to borrow information within the concepts, which we find in many different ways of doing statistics. But, that concept is quite key. It's key, and getting experience in that is very, it's very useful. And that has driven the field. People kept thinking more and more about clever way of how to do that, which are flexible and so on, didn't kind of shoehorn the data into stuff. But then, sorry, it's a long answer, but this is a big question.
This is a big
but
question.
then basically, with the advent of the very large P, it seems that we were going backward because suddenly, the method which is coming at was one at a time, univariate analysis and meta-analysis. And I thought, what's going on? I just really was a bit taken aback and a bit discouraged at that point because, of course, the advances were done with that. And I thought, well, what's the place for, putting back the structure? But then, basically the field caught up and started to think about multivariate analysis, even with large P and the idea of shrinkage and so on, and got expertise. But for a while, I think there was a bit of a dichotomy between, the advances in the genetic, which was using what was needed at the time, kind of simplistic statistical ideas, well done. And then, the complexity of the data underneath, but it was so complex and so large, it was really difficult to tackle. And then people started to get expertise in, high dimensional data analysis and Bayesian, sparsity price and all that. But then, it was computationally became really quite hard. And so I think in the end, we should aim for a happy marriage of approximate joint inference, because in that framework, in this framework of very big data, full joint inference with all the bells and whistles is just not scalable. It just doesn't deliver for the science what people want completely, So we just have to, get away from oversimplistic thing, but somehow do some approximation, good approximation of joint moderns, good scalable tools, but understand, how we can preserve uncertainty. So I think that's the way, the field is going, and this middle ground. But we still want to deliver interpretable inference focusing on understanding. This is, I think, where our core strength is, rather than, pure prediction machines, which, is a speciality of another field. It's not that we can't do that, but I think our core strength is really interpretable inference and preserving, quantification of uncertainty.
Yeah, things have changed a lot. I mean, I was brought up as a really strict subjectivist Bayesian ideologically. And in the early 80s, we were putting that into practice, elicitation of subjective probability distributions about the likely effect of a new cancer drug, for example. And we were interviewing oncologists and putting that and showing how that could be included into the design of the study in order to get a more realistic power calculation, not based on some optimistic desire, but on a realistic expectation of what the drug might deliver. And so that's the kind of thing we're doing in the early 80s, still really important. But then, of course, by the late 80s, it moved into, as Sylvia said, what you might call full probability modeling, taking advantage of hierarchical models and things like that. And that's what's accelerated enormously over the last 30 years. And it's been very exciting to be part of all of that. From that transition where people were saying, oh, this Bayesian stuff is all very well, but now, it's extraordinary what has happened. So I'm fortunate. I'm a non-executive director on the UK Statistics Authority that runs the census and the Office for National Statistics. This is official statistics, official government statistics, which used to be the most tedious area of work in which I had no interest whatsoever. It is now the most exciting area to work in, I think. For example, we've been running the COVID infection survey, one of the, absolutely envy of the world, the, only, I think, large-scale survey that's been going on since April 2020 of both, looking at both people who are antigen positive in terms of having the virus, but also looking at antibodies levels in the population, stratified by age, by area, and by other factors. Now, how that's done is done in a full Bayesian, multi-level regression and post-stratification model, full MRP model. Got Andrew Gelman in to help on that. Running really sophisticated analysis, bringing together, as Sylvia said, our understanding about the potential error rates and so on into this full probability model and producing outputs. I was teaching journalist statistics last week. I have to explain what a credible interval is to the journalists.
Yes.
It's extraordinary because it's all the official outputs from Office for National Statistics are now in terms of credible intervals. Not just that. There's a big discussion in this country about whether to have another census. We just had a very successful one in 2021 during the pandemic. Are we going to have one in 2031? The decision will be made next year. So obviously alternatives are being looked at, and the alternative is a massive Bayesian dynamic population model that brings in, obviously the past data, but in terms of the transitions over time, is bringing data from multiple data sets from all over the place, merging them in to produce a credible interval, a posterior distribution for how many people of different, in every sort of stratification there is in society. And that's currently being developed and, compared with great, you can develop it on all the data up to 2021 and then compare it with the census. Fantastic calibration opportunity for this massive model. Now, as Sylvia said, the problem is we can write down what we want to do. You can't do it. It's computation. It is so massive. So a huge, sadly, even with modern computing, a huge amount of effort is purely how can we actually do this and make this a sustainable technology that can produce population statistics incredibly rapidly at a very micro level. I mean, it's extraordinary. And isn't this amazing development?
Yes, it's
extraordinary. And yet, I still go back to the importance of subjective probability assessment. I've just been at quite a big role in a major public inquiry in this country into infected blood in the 70s and 80s, and we had to conduct a subjective probability assessment because we had no data about a particularly important factor. So that doesn't go away.
Yeah. So it has been quite a tide of revolution foundational ideas, but modern computation.
Yes.
What a time for statistics.
Yes,
Yeah.
yes.
And that's sort of just evident by just talking to you, and also what is possible these days. And
yes.
still,
Yeah.
the
But still really challenging to actually
Still
just do it.
Yes, really challenging. That's why approximate temperature, there's a lot of research on scalability and how to combine scalability with, being careful, understanding what's going on. It's really an art and very interesting area, as you say, to actually put massive stuff into practice. Yeah.
And also how divide and conquer. This has
Yes.
become just like such an important
Yes,
topic
yes.
with all the problems that you're talking about. So we have heard foundational talks, we have heard about competition, and both of you have made such incredible contributions in theoretical statistics, applications, and policy work, and working with the government. What do you consider, your fan clubs consider, I can say what is your most important contributions, but what do you consider your most significant contributions to statistics and to the world?
Oh dear. So I go, oh
Yeah.
dear. Oh yeah. Well, the first thing to say is that, I've had a couple of good ideas, but they wouldn't have gone anywhere if it wasn't for the people that I worked with. So I don't like saying my contributions, because pretty well all of it was done in deep collaboration with some extraordinary people. But if I could just tick off my, my back catalogue, my bestsellers in the back catalogue, I think
Bestseller.
the best,
Very
which of course they're the citation earners. What's the citation? I checked on Google Scholar. What's the citation? First one was really with Stefan Richardson on putting probability into Bayesian graphical models.
Yes.
But that actually, I think that was my insight. I spotted that the work that Stefan and others were doing on graphical modeling for contingency tables with undirected graphs and starting to move towards directed graphs was directly applicable to uncertainty in AI. And I think that might have been my idea. But I couldn't go anywhere with it without working with people like him. So that was the first one. That's good. And then, of course, moving from there from Bayesian graphical modeling and realizing the close connection with Gibbs, how absolutely merged with efficient Gibbs sampling with graphical modeling, and then that led to the bugs work and that sort of thing. Again, in collaboration with lots of people, which I think was influential in getting that sort of complex Bayesian computation into the hands of everybody.
Yes.
So I think that was influential. And then the next thing really was curious. It was because of being involved in public inquiries into healthcare scandals, the business of making more rigorous performance monitoring, both sequential and cross-sectional between institutions. And that required taking classical sequential analysis, sequential probability ratio tests, Q-sums, and producing risk-adjusted versions. So I think, again, in collaboration with others, developing risk-adjusted Q-sums, risk-adjusted sequential probability ratio tests, everything, was really cool stuff and was quite easy to do. And then what's nice about that is that those techniques had come out of industrial quality control. We adapted them to medicine. They went back into industrial quality control. And people realized you can do much more complicated. You can do essentially sequential monitoring, all this stuff, with covariates, which hadn't been realized before. So that was a really nice movement. We stole those techniques, adapted them, improved them, and then they went back into industrial stuff. And then I was thinking about this. Finally, I think I suppose what I'm best known for now is what you might call as a performing statistician, to turn stats communication into an art form, and not just, but in terms of and not just sort of media stuff and TV programs and radio and stuff like that, but also in writing, trying to write in an entertaining way, articles and then a book, Art of Stats, and that's what I've been doing now for 15 years, and I really like it. And I think this idea that explaining statistics can be fun. You can put humor in. You can put also lots of. You can use stories, storytelling, good graphics, and it's a performance. And I think that, in a sense, is almost my biggest innovation, and one that I'm, feel. Well, I'm just going to carry on doing that, I suppose, until I drop off the perch.
And this is incredibly important, and as we have discussed, that you need the past 30 or so years of deep foundational understanding of the field in order to do this kind of innovation.
It really helps when you're sitting teaching journalists about statistics. I did 2 hours last week, great gang of journalists teaching all about the stuff. It helps to have done 40 years beforehand of slog, of the methodology, of doing countless studies, referring vast numbers of medical papers and so on. To have done all that, and then I can get up and talk about, and I'm quite happy to spend ages explaining what an odds ratio is, what a hazard ratio is, and do it again and again and again to to the journalists, and then now credible intervals, Bayesian hierarchical modeling. I have to explain some of that to them. I don't mind doing it. You know, I'm old. I'm not going to do anything clever anymore. So I just like doing that stuff, and it really helps. Yeah, to have had a lot of years' experience. Yeah.
Of course, we are really, really thankful for that impact that you made, Sylvia.
Well, I totally agree with David. You know, it is all the collaboration I've had. You know, this is really, it's a group endeavor. I think, you know, I continue try to tackle, you know, methodological challenges arising, say, in environmental and spatial epidemiology. That was my first field, and then biomedicine and genomics. So in the spatial domain, you know, maybe one of the first piece of work which, you know, delivered kind of concretely was a very simple thing, which was to look at testing the association between two spatial processes and developing a modified kind of t-test. And that has been, you know, quite widely used in ecology and so on. And then I really got into the interpretation, you know, the difference between studies which use aggregated data, so where you lose basically the individual kind of links between, you know, exposure and effect, and you know, so this kind of ecological and understanding, you know, the kind of how the model change, how the bias occur when you actually change level, you know, of data from individual level, and this, you know, so somehow I really tried to make an impact on explaining, you know, what you can, how you can interpret, and what you've got to be aware of these ecological bias in ecological studies. And then, you know, through that, I really got interested in heterogeneity, because, you know, in epidemiology, you need to exploit heterogeneity to understand, you know, you need contrast. And then thinking about, you know, that there are typical subgroups, hidden subgroups in your data and in your clinical problem and so on. And how do you, in a flexible way, you know, discover these subgroups with that? And it seemed to be that most of the tools were very, you know, just made assumptions, harsh assumption. They had to know in advance, you know, the number of groups. And then, and also, you know, in a funny way, I was also very interested in hierarchical model and be flexible at the second level, not you know, really pushing everything into an assumption of exchangeability at the second level, but and you had encountered that for performance monitoring and so on. You know, the fact that it's so influential, basically the structure that you assume at the second level, and that assuming the outcome, you know, the simplistic exchangeability assumption. I was dissatisfied. I wanted to know, you know, what was important, that what we could replace it. So both at the actual data level and at the second level, I really got interested in mixture of distribution and a flexible way of you know, discover structure in the data, and or using, you know, not forcing unrealistic you know, an unrealistic expectation on the parameters at the second level. And so I think, you know, one of the most, you know, very exciting piece of work that I did, and then started a long collaboration with Peter Green on mixture model, and thinking about, you know, clustering and mixture and in all their forms. And I still work on in that area. Now trying to do it for big N, for example, also trying to do kind of semi supervised clustering where it gets informed by the outcome. So it's not just blind, unsupervised, but there is a purpose to your clustering, which helps you to interpret and so on. So I think this maybe, this was my main, contribution. Of course, I've worked also on, on genomics, variable selection, and bringing multivariate dimension to this big context of large P, which where multivariate was quite rare for a while, and really tried to say this is not sensible to keep going back 40 years of statistics and treat them as IID in a way. So let's see if there's structure we could exploit, and let's try to do that. And I wasn't the only one, but I think I helped encourage people to not lose heart and try to be ambitious in terms of finding multivariate structure in very large genomics data sets, and how they could be used to networks and so on.
And part of our contribution was together. With Wally Jokes, we were the editors and
of that
a
book.
lot of the authors of Markov-Chain Monte Carlo in Practice, 1991, which established essentially the whole field of MCMC and Bayesian work. And it's still really good.
It's still
great
good.
stuff.
Yes.
It's great stuff. So, and that was largely because of this extraordinary workshop that Sylvia set up in France, where everybody, all the Bayesian stuff in MCMC, all came together. And it was one of the most exciting
And do you remember I managed to make everybody stay in this chateau.
Yes, stay in this chateau, yeah.
A kind of hotel chateau.
There's particular times when there's, ideas are just buzzing around.
Yes.
I always imagine it must have been like, Heisenberg and everything when he was doing his stuff, and meeting Niels Bohr on train platforms and stuff like that. So it felt like that in 1991 with the MCMC revolution happening.
Yeah, it was 1992. That workshop was 1992, but because I stayed in BSU on a sabbatical in 1991, and it was a year after.
Yeah.
I'm getting goosebumps just listening to you.
No, it was. I remember Stefan,
Yeah.
giving the first lecture about graphical model and how to moralize graph. I love that word. I think one big success of this thing was your terminology.
Moralizing
graph.
That was my.
That was huge.
Really.
Always this helps, but at that time, really, all the ideas were coming. It was a confluence of many people, and things were coming together, and everybody was learning from each other's work and just proliferating. That's just a wonderful time. So I feel like we are standing at a similar time now with statistics and data science coming together, and new ideas from machine learning community being presented to statisticians. It's 20 years of Leo Bryman's paper in statistical science, statistical modeling, the two cultures. And at the time, algorithmic modeling and stochastic modeling were quite two separate worlds. But we have seen convergence of these two worlds. Many times I hear people thinking about causal estimates and then starting to use machine learning methods for assumption lean inference. And we are moving towards more of an unified view. And you have led your societies during this time when people are battling and coming together with these different phases of statistics and data science. So some thoughts on how do you feel statisticians have done in the age of data science?
Well, I very much welcome this development. I think there's a lot of common ground and mutual benefit, to be had. And indeed, with the importance of evolving a discipline during my recent presidency of the RSS, I set up a data science task force to really see the engagement of the society, with the evolving world of data science and the data scientists, and which came up with a series of recommendations, which are being implemented both for practitioners and also for the establishment of a new journal. So this is really to try to get a conversation going and to get ideas propagating from, sometimes narrow technical subfield of which they're developed so that they could reach across the whole of the data scientists who also are quite fractionated in their specialities, computer vision. People don't necessarily talk to the econometrician and so on, and statisticians. But I think, one thing which has come is that, at the core is that our business is basically solving real world problems and core, the role of practice. And I think, this is, but because I'm an applied statistician, I've always thought that. But I think this, the data science has really brought that, that realization to the core, and I very much welcome that. And as I say, reducing fragmentation and silos, I think it's important, having shared vocabulary, but realizing that there's some really difficult connection to be made, when a very specific loss function is used, in an algorithm. What does it really do? What constraint does it put? How can we understand that? In another way, if we were going to modulate it, as for example, as a prompt, how do we translate these things and get to the nitty gritty of why things work, why things don't work, and where is the magic in there? Because there's no free lunch. There's always some assumptions, and I think statisticians are very good at digging those out and not letting them buried in a machine. And once you dig those out, you can understand, the properties and have a better overarching view. So there's a lot of conversation. On the other hand, there's really good ideas in this algorithm, and if they work, they do something. But to trust them, you need to understand, to have more understanding. And then, of course, we still have to keep the fundamental idea that probability needs to be used for quantifying uncertainty. This is our bread and butter. And I think David probably will talk about, what we could bring to
Mm.
design of training and evaluation of algorithm, which you've really, had.
Yeah, I've had to change my mind
comments
in this area, I think, because I used to be a full probability modeler. If you were going to have some sort of technique that was going to be used for something, I wanted it to come out of, an understanding of how the world works, a stochastic model. And I didn't like these sort of just pulling a formula off the shelf and, seeing if it worked or not. I think I've changed my mind now, because I do believe that, if you are working in an area of where machine learning is being used in terms of some sort of algorithm that's being used in society for some purpose, then it's an algorithm. And actually where it comes from, I don't care now. I don't think that's so important. But the model-based one's always so nice because it feels, I should have an idea of its properties even before it's being used because of the way it's being constructed. But I've become very skeptical about, uncertainty intervals that are calculated assuming the truth of the model, because the model's not true. And I've seen some where people do this model and come up with some tiny little uncertainty interval, which bears no resemblance to reality. So I think actually I no longer care particularly about where the algorithm comes from. But as Sylvia emphasized, now the statistical issues really arise in the evaluation of the algorithm. And everyone's really concerned about this. Is it fair? Does it work? Can you transfer everything? These are now completely statistical issues. They're to do with populations, to samples, and things. Not in terms of the construction of it, but in terms of the valuation. So suddenly it all comes back again. And actually, we might know a little bit about this. By the way, we know something about this. And yet again, you have to go through this business trying to convince people that we've been doing this for decades. If not, we know something, we can help. And of course, that will eventually, is getting through. That working out the trustworthiness of algorithms is essentially a statistical issue. But it takes some time. And in the meantime,
So
of course, we
much.
get so fed up with, I'm
Yeah.
using this machine learning
Yeah,
technique,
there's so
logistic regression, and trying to make some fake distinction between statistical and machine learning. I just don't bother anymore. I think it's such a waste of time. Just say, look at it much more into what's it going to be used for. If it's a formula, it's an algorithm, let's just treat it as such and then work out whether it's any good or not. Well, either we could have a go at trying to do it from its internal properties of how it's developed, but ideally it should always be based on some external validation. So I think there's been so many false labels, and I still get very irritated about people, talking about AI. I've been working on uncertainty in AI for 35 years now. People, talk about this stuff as if it's a new domain. And I think we should really concentrate much more in terms of what's the thing being used for. And that is the crucial thing. It's function that drives everything. And with the labeling and everything. Yeah.
And also maybe how the data are collected and
how the data is collected and how the data for training, for example. And there's so many biases. And there's a recent review of algorithm. Even in a field where AI should be, or data science should be really good, like image classification. If everybody uses the same data, and that data has got some characteristic that it's easier to classify because you picked up some subtle stuff. Then you churn up rubbish. And I think during COVID there was such a hype, and for example, diagnostic severe patient by doing this, and all that was proved that it was just not reproducible. This is really
any algorithm I no longer trust. I don't think any claim based on its internal, historical performance. Why do we even read this stuff? Prove to me this is going to work in a new area.
So both of you have assumed leadership of different forms. Sometimes it's of an unit, sometimes it's of a scientific research group, professional societies, or a center. What has been the motivation, guiding principles and rewards of building something like this and leading something, and also spending time on administrative work?
Oh dear, I'm not a very good leader. No, I'm the most reluctant, grudging leader that you've ever thought. I never wanted to be head of anything. I never wanted to run anything. And mainly I've avoided it very carefully. I haven't applied for leadership roles because I know I wouldn't be very good at it. I'm not very good at managing. I'm not very good at organizing things. I'm not very good at administration. I can do it, but very grudgingly indeed. So I feel very fortunate in that I've managed to find my way into quite a good position while never really having that much responsibility. And I think this is a great achievement for myself. I'm extremely proud of it. The point is, I can do so. I know, after work, you've got to, as you get older, you learn your strengths and weaknesses. And I'm quite good at inspiring people, I think. I'm quite good at educating people. I'm good at communication. And I'm a very good collaborator. I love working in multidisciplinary teams in particular. I really, really enjoy that. I do not like being the one being out in front and so on. So I've always tried to avoid that, and I've done very well. The other side of it is that I quite like working with people is it shares the burden. I don't know if we're going to get onto this, but if you start appearing in public, you get kickback on it. And so, for example, when I was doing COVID work, it was publishing stuff every week, and it was all jointly with Anthony Masters. And when we got the abusive tweets, somewhat threatening, it really helps to somebody else to share those with, and to take the reaction, to be inspired by their reaction to it, rather than one's own reaction. So I really like sharing out the responsibilities in that sense.
I think
you actually did.
You've done. Sylvia's done it properly. Yes. She really does it. Yeah.
Yes. Well, I think my personal motivation, had been to really defend the discipline, and having started by working alongside, but basically, sort of alongside but slightly dominated in a applied environment and in, for example, in an epidemiology environment. I just spent a lot of time, sort of making the case for good method and for our independence. We didn't have to just work on the problems that were put in front of us. We could abstract them. We could go, have our, other ideas and so on. And so I just felt
This was in Imperial College.
That was already in France.
Okay.
For example, in France, I was responsible for the biostatistics group, but within a big epidemiology unit. So there was a head, and basically you had to sort of adapt your line of research to some of the purpose of the whole unit. And as I grew more independent, I became bolder, and I said, there are some interesting things I could see that I can do. If it doesn't fit in the particular purpose of the unit, I still want to do them. So that also pushed me to move from France actually to the UK, where I felt it was a more open environment, and when I joined Imperial, I could work on spatial statistics and things like that. I could work on genomics. I could work on longitudinal data. I had loads of ideas in many domains, and I could do all of those without, having to toe a line. But nevertheless, I was still having to fight for biostatistics independent among a large clinical school and among, and because, in terms of grants, for example, and income, we are not bringing the big money. We don't collect data and so on. Our grants are small. There's always been an imbalance. And I felt that, it was a bit exhausting to make the case for biostatistics. So that's why when basically the directorship of the MRC Biostatistics unit came, I applied for it because I just wanted to be able to, be with a group and have the responsibility and not and be more or less, defending biostatistics per se and showing, building links, but from a basis which was an independence basis and a per se recognition. And also, I've always liked to, I've liked to have PhD students. I've liked to train young researchers, and I very much like to interact with people. I'm a people person, and sort of. Solving conflicts is something I'm good at least perceiving conflicts and try to solve them before they get, and just helping young people or people in general to in their work life. It is something I've been good at, and I care about it. So that one of the rewards have been that I have managed to actually help the career of many young people, in particular young women, but not just. But nevertheless, I took an interest in helping because, I could relate to some of the constraints, the struggles, and so on of women statisticians, and I took an interest, and I felt having leadership position gave me a good platform to do that, and also some power to concretely help them, make things more flexible, put in in place structures that nurturing structure. So. And also I felt, taking leadership just helped me to be more creative, because then you could, decide this is really an area, let's think, and let's, that I could identify areas where things could be really productive, methodology creative, but impactful, and then you could get them going. And I took pleasure, I found that was, I really was proud of being able to do that. And so so the administrative, I was had fantastic help, administrative help, for example, in the biostatistics unit, the administrative help is, with that, team effort, absolute team effort, and all the leaders. So I always found it, I was leading, but I had a collective of senior senior researchers working, alongside, and also very good admin. So it hasn't been. And similarly for the RSS, the actual staff is excellent. And so in a way, you can be creative, and the admin is there, but you kind of.
So one prestigious leadership position that you both have held
Yeah.
is the president
Yes.
Royal Statistical Society, and as a statistical community, we have statisticians in the workforce, in government, in industry, and in academia. What was it like to put forward a vision for the broader community?
I'm not sure how good I am at the vision thing. It was when I was president, obviously you do all the chairing meetings and that sort of thing, work very closely with the chief executive, who's excellent. And I suppose that I was mainly promoting this idea of statisticians, because that's what I do, of putting your heads up above the parapet and actually taking on a public role, which is, what I emphasize. So establishing this idea of Royal Statistical Society ambassadors and so on. And so those were my particular interests, which is, of course, what I promoted, and engagement with the media and so on, which I think is timely. I didn't know the pandemic was coming, but it was it was quite good build up to it, to be ready for it. But I didn't engage in any large initiatives, and so I think I've got to say what Sylvia has been doing with data science in the RSS is extraordinary. And as I said to her, I wish I'd done it, but it's not what I would do. So, but over to Sylvia for that one. Yeah.
Yes, well, when I was president, the data science, I had the idea beforehand, prepared. I was flabbergasted when I was asked, to be honest. And then I thought, well, I thought of what can I bring to the society, and what, somehow became a bit more daring by then. And I thought, shake them up a bit somehow, make sure that, there's a real future. And I was really scared by this NSF report. Yes. Saying it's a crossroad. And I totally agreed with some of the things which were said. And I thought, well, we at least need to read it and see, are we on the right path or not? And then start from there. And then COVID hit. And so basically there was this dual thing, and the alliance with David in making this, because I knew very well I wasn't, I was a good biostatistician and I could deal, but, the actual communication, and we needed a group because there were so many things we needed particularly at the beginning, to be able to comfort each other about ideas about what to do and stuff. So it was fantastic that David agreed to, I felt there was no choice. I had to do something. And also, I think everybody in the task force really got together and was incredibly generous with their time and supporting each other, so that we could engage, do the best in our field, but have the comfort of exchanging support with the others, particularly to get going at the beginning. So
but everybody is so busy. I mean, just extraordinary. Yeah. I mean, just right across, the scientific world and elsewhere in society. But statisticians were so busy, so in demand, which is quite right. Yes. But a lot of pressure on people.
But we could share, we could quickly be au courant, we could quickly share what we knew was going on, what was the upcoming issues and so on. And we had different roles in different committees and so on. So we made, I think this task force worked really well for the urgent.
And I really loved in your presidential address how you unified the data science missions with the COVID-19 crisis, so that we have the infrastructure that we can pivot nimbly to blend the two. So you two have been such generous mentors. Even in the last 4 months, I feel incredibly grateful for your mentoring and support. And you have given back to the community and to society at large in so many different ways. But who have been influential in your life as mentors and colleagues and shaping your thinking and shaping who you are looking back?
There's so many. As I said, I've done almost everything in close collaboration with people, and a lovely group of people. I got to mention Adrian Smith. When I was 18, I arrived at university in Oxford to do maths and find this young man who was, they got this bizarre medieval term. He was my moral tutor, which is considering most of our tutoring was done in the bar of the Lamb and Flag. Is probably not a very good indication of his teaching. But he was an extraordinary influence. I mean, now Sir Adrian Smith, President of the Royal Society and things, so, but, I've known him for 54 years. No, how old am I? No, how old am I? 51 years. I've known him. And so I was very influenced by him, partly because of doing stats. And he was translating De Finetti at the time, so he's up to here in subjective probability. Probability does not exist, which he told me when I was about 19. I first learned that probability does not exist, and I've never ever shifted from it. It doesn't exist. So I believe that, I've known it for 50 years, and I can still get into violent arguments with physicists at this drop of a hat when they insist that probability actually does exist. Anyway, so he was enormously interested, but a lot of it's just because of his personal approach, his passion for the subject. The fact that this was something that you did shout at people in bars about, what is probability? This is quite, and I still will shout if some, I'm a very mild person, but if someone starts, telling me what they think probability is, I'll rise to it. I will rise to it. But so that sort of, and has never left me, that this is a subject that is important. What is a model? What is uncertainty? What is probability? These basic fundamental ideas are absolutely crucial. And throughout my entire career, never lost track of the fact that these, and it happens all the time. Every time I'm talking in the media to a journalist, these absolutely fundamental ideas of, what does the data actually mean? What is uncertainty? What does it mean to say we don't know something? You come back to it all the time. So I was very privileged to have an influence that was not only interested in the technicalities, because he was my maths teacher. Learned my maths from him, but also in terms of the absolute importance of the fundamental, in a way, philosophical ideas behind the subject, which has been. So it's not just a bag of tricks. No, there are deep ideas behind statistics, and I've always reveled and really enjoyed the fact that there were deep ideas there.
So, I had the good fortune, to meet exceptional colleagues and mentors throughout my career. And as I said, the first person, which I already talked a bit, was Philippe Lazare, who was the head of this epidemiology unit, who actually trusted a probabilist, a Godic theory person arriving and saying, is there anything you're interested in which we collaborate? And he actually crystallized a very interesting problem about, we're using spatial data all the time to look at environment and health. We're worried about the non-independence of the data. We think the degrees of freedom are not what people are saying they are. Can we do something about it, not too sophisticated? And, he just trusted me. This is a real good problem to somebody he hardly knew. And so I think he became later the head of the institute. I think he was polytechnicien. And so came from this very high level, school, engineering school, but where you actually, learn, very broad culture of quantitative science. And he was very open. And he just gave me confidence that I could bring something to an applied area and that I could contribute. And that really set me on the path to become what I've become. And then the second thing, which we've already alluded, event, was that I did spend my sabbatical, 6-month sabbatical in 91 in the biostatistics unit in Cambridge, which is a hotbed as you know, of conversation and excitement about, the possibility of Bayesian statistics. And I talked to David, and I talked to also, in particular, to Wally Gilks, and I also talked to Nikki Best and all the students, who were working. But in particular, I started, a collaboration with Wally Gilks when we realized, because I had come with some issues about measurement error and the way people were analyzing some data, which is a bit unsatisfactory in epidemiology, the way they were dealing with the kind of measurement error. And we realized, oh, well, we can, why don't we try to use, graphical, hierarchical, graphical modeling idea for a measurement error problem. And we started to, conceptualize that. And he was so generous with his ideas. So I think Wally, he came then to visit in France for a sabbatical himself, so we could carry on, after I went back to France. So he was very influential to really give me confidence, because in France, the Bayesian, it was really a bit of a struggle to get the Bayesian perspective in mainstream. It certainly was not in mainstream university and academia, but in terms of biostatistics, I think it was quite well accepted. Maybe the workshop that we organized with the INSERM workshop that we co-organized with Wally and David, which we've talked about in '92, was probably, a very good starting point for biostatistics in France, because, the audience they came from Europe, but there was a lot of a big French contingent. And I think it really helped to spread that, the word and get the acceptance. And that was very different from the actual, very theoretical statistics point of view that most of the university departments were developing, where they really did not like Bayesian statistics in France at that point. And another person I want to mention is Duncan Thomas, who I met also at the same time at a workshop in Rome when I was talking about ecological bias. And we discovered that we thought very similar. He was working in environment and health as well. And we just hit it off. We discovered that we really thought about the problems in the same way. And this carried on for many years. He also came to visit in France. And throughout the years, I've always felt that it was somebody I could bounce ideas with. And he was also very generous in sharing. And for example, he's the first one who signaled genetics. He told me, Sylvia, this whole genetic field is very interesting. It's just coming up. You should have a look at it. And he actually, he's the first one to actually point me in that direction, which I developed later on. And then finally, Peter Green, who I met through the European network, where we've developed, as I explained, my passion for, my motivation for mixture model, coincided with the fact that he was developing this very innovative methodology of reversible jump. And then I had so many problems where I wanted to apply reversible jump. So we got together, and he was very, I think he was happy that he could see the applications. And so we really worked very productively together over many years. And, there's been a great, part of my career. Yeah.
Can I just mention my sort of second part of my career, is this performance bit, because I've been influenced by a different group of people, not the sort of technical statisticians. Although I should say, Kevin McConway is a wonderful Bayesian statistician, but who has absolutely dedicated himself to improving the way that stats is covered in the media, and who are so grateful to have somebody who is there doing similar kind of work, and you can check what you're saying with them, because you're on your own, and people say, and actually you do want to make sure all the time, is this sensible what I'm saying? Is this criticism okay? And so enormously valuable to have a colleague you can bounce off what you're saying. But then, other people just working in the media have been so influenced by, I don't know, Tim Harford, the economist who does more or less on the radio, has been just by, I wouldn't say personal mentor, something, but just looking at how they work, how they communicate, the language they use, their tone, enormously influential. And finally, my colleague Alex Freeman, who's a scientist, but she has worked for the BBC. She was directing me for a TV program, and I've worked with her in Cambridge now for years. And again, someone who's very influential because of their communication knowledge about constructing a narrative, telling a story, the visualization of issues. That visual, those visual skills for telling a story is incredibly important. Stuff like, I don't feel I know this at all, so I just have to try to learn this of other people. Yeah.
So this is a very nice segue to my next question, which is, I know, very dear to your heart, communication. And for mathematical, statistically oriented and trained individuals, it's often a challenge. First, communicating with non-statistical scientists, then lay public, stakeholders, and you have cultivated this as an art, and you have written about it, and the challenges are quite different when you are presenting orally or written communication. So can you share some experience and advice for us?
Oh dear. Well, first of all, it's not for everybody. Definitely not for everybody. You have to play to your strengths, and I'm actually quite introverted. I don't naturally go out and shout at everybody, but I found out if I embed it as part of a performance where I'm really prepared, I can do it, and I actually quite enjoy it. I like the preparation of it. I like the, constructing the narrative. If I'm going to do an interview, I like working out how to tell the story, and to be able to do it with a lightness that doesn't put people off. But it really does require effort and thought and time. And as Kevin and I wrote an article about this for Significance, just the main thing was it will go wrong. You will go wrong, always. And you have to be able to pick yourself back up and you think, oh, why did I say that? How could I be? And it's sometimes because other people have taken advantage of you and mangled a quote. I've had ones where people took the first half of one sentence and the second half of another and put them together, changed the tone. The nice thing about that is you think, well, I'm never going to work ever with that person ever again. And I'm going to tell everybody else not to work with that person again. So one can get your own back a little bit if you're stitched up. But anyway, for me, it's been a very positive experience. And I do recommend that that everyone should try to some extent to explain what they're doing. It's absolutely, I think it's part of the job. Yeah. So I'd say you start obviously by trying to explain to your colleagues. And that means, I think, I developed through just trying to give good talks. That's what I did for ages. I tried to improve, in a way, the entertainment value of my talks, of cutting down on the maths, of better visualizations, talking direct to the audience, even introducing a bit of humor, a bit of personality into it, not too much, keeping to time. The crucial thing in all of this is treating the audience with respect, always, which means looking them in the eye, keeping to time, informing them, entertaining them, so teaching them something, and not doing it for your benefit, for their benefit. It's for the audience's benefit. So you have to have sympathy with the audience. You want them to benefit from it. And once you've got that idea, then I think it's a natural progress from giving good talks to your colleagues to then, giving good talks, at conferences and things like that. And then, expanding outside, if you feel like expanding outside that, which is both in written and performance. So, writing blogs, going on Twitter or other social media if you feel like it, writing articles for online magazines, or even writing for print magazines, submitting those. And then my thing was start doing science festivals, which is a very good start, a very good lead-in to do science festivals once you've got some good stuff to talk about. And then I got media training. I got Medical Research Council gave me 2 lots of media training, incredibly valuable, really useful. Then work up local radio is a good basis for it. Start making your contacts with your journalists, making friends with journalists. And we're very fortunate in this country. We've got a Science Media Centre that acts as a conduit between journalists and scientists. And you can develop relationships, and they start contacting you through them or directly. You start helping them. The other thing is to be helpful all the time. Be helpful, because then people come back to you and ask you to do the nice stuff. If you've helped them on a story, even if you haven't got your name in it, then you start being asked to contribute. So I mean, and it's a long slog, and things go badly and things go well. The other thing is improving one's written style by studying journalistic style of scientific reporting and getting the feeling. So you have to, I mean, not only do you have to ditch scientific jargon, I mean, I would never, ever use terms like statistical significance, confidence interval, p-value, they all go immediately. You have to find out other ways of saying this. So you have to ditch every way you've normally said it. You have to ditch the academic style of writing. You have to even ditch, I think, a literary style of writing. So you do start sentences with and, so, and but. All these things which we're told we shouldn't do. Yes, of course you do in journalism. You can use sentences without verbs. You can use alternating length of sentences. So pure written style, studying a journalistic style of writing. And I really enjoyed doing that, developing that. And so these are all I think, good skills that take some time. And I'm going to just check, because I did make, this is one point I need to, the other thing you do is prepare what you're going to say in terms of bullet points. One of the great advantages of doing interviews over the COVID is that they weren't done face-to-face, so that you could, you're always talking to the green dot on your computer. And so you can, as I did, you set up your own autocue. You can scroll through your points underneath, and people can't tell that you're reading them or looking at them, because so it's just what presenters do, reading an autocue. You set up your own. So you can reel off huge numbers of statistics as if you know them. And in fact, you've got them in front of you. Anyway, I shouldn't give away the tricks of the trade.
Yes.
Okay. Yeah, so what was I saying? Giving good talks, writing popular articles, get training if possible, observe others, who does well, who does a good gig, who would you want to listen to, who do you want to watch, get feedback, try again. You've got to identify what you're happy doing, what fits in with your personality, your characteristic, what goes down well. And this means sensitivity to the audience, knowing what makes them laugh or pay attention. You can tell when you've gripped an audience, because they go quiet on the edge of their seat. You can just tell exactly what's going there. Are they enjoying themselves? I think a crucial thing. And the other thing is, you've got to develop your skills, get feedback from friendly colleagues, and things will go wrong. So get support. Have people who are critical friends who will say when things could be better. My partner's my best critical friend, because she'll just ruthlessly say when something isn't very good, or she'll also say sometimes when things are actually quite good. And then, as I said, because things go wrong, and especially if any abuse starts flying, it really helps to share that.
Having a community audience.
The community of support is absolutely vital. So you don't feel on your own when you are quite vulnerable out there, and you will make mistakes. And so it really helps to have people to be nice to you. Yeah.
I don't have much to add. I just, in terms of communicating, I think to your peers, I've always enjoyed that and really tried to get better at it, and indeed give good talks and illustrative example and go off lib. You can prepare a talk, but I think often when you just go off, add an extra just in response to an idea, in response to somebody looking at you at the right time. I think it just gives this little nugget of insight and some personal reflection that you could put in, which makes the talks, which makes the audience. So in terms of communicating to students and to peers, I think I was good at it, or I enjoyed it, and certainly improved my graphic style. Try to fight with the LaTeX. Really like PowerPoint for the speed of preparing, and LaTeX is really it's fiddly, but it's also. But it's only during COVID that I started, so I've always been, methodologies basically. So these were the type of talk. It's only during COVID that I understood the importance of, communicating in a simple way to, for example, when you're in an expert group and you've got 1 minute or less to make your comment, there's a video thing, you've really got to prepare, I'm going to just make that comment at that point. I need to make it clearly so that they pick it up. They're not statistician, and find the right time to do it, because, some people talk a lot, some people talk less, whatever, so it's a bit of strategy of when to intervene to actually make your point and communicate in a simple way. I've learned a lot. The few things, I totally agree with David, you have to play to your strengths. And, my strengths were not doing interviews with the white media. I did try we wrote a first article together for The Observer, if you remember. And I saw how, I made bullet points. I sort of made all the bullet points, and David completely rewrote them in a much more simple, style. And I could see the skill that you have to, that he had in terms of translating the same. We had exactly the same ideas. We wanted to say the same thing, but translated in simple terms. It really is a skill. But as I said in my presidential address, I think it's a very important skill. And I think, let's say in my education or in my thing, I wasn't particularly encouraged, besides communicating to your peers, that was a teaching, having a good teaching, being a good and not a boring teacher. That was all which was asked of us. And I think now for the young people, I think I would repeat what I said. I think they should really try to learn to enjoy community to really wide public as well. Of course, it's not for everybody, but everybody should try and realize that. And they should enjoy it. This is a bit scary, but it is also very enjoyable. And I think we have to tell them that. We have to tell the future generation that this is very important, because, in terms of impact and in terms of bringing us closely to impact of our method and defending our discipline. So I think we should encourage more training and more, role models should encourage the young people to pick that up.
We also have to find out a system to reward them. Because if our traditional promotion is rewarding one kind of work, we cannot ask the young people to take such a risk.
I know.
Absolutely. And actually, Cambridge is good in terms of public engagement, is explicitly into the promotion criteria. And I enjoyed being on the promotions committee.
Yes, no,
to put that into
absolutely.
practice. But I should say also, I'm an old, white, high-status man. And so I have an easy ride compared with what other people might have. And so that's why it's essential that there is who's got a very strong support group for people who try to do this.
Yeah.
I certainly appreciate that. And Sue, we heard a lot about your contributions in terms of statistical methodology. Would you like to share one or two collaborative or examples where your work has really translated into practice or policy change?
I think this is a very tall order. I was just, to be able to say that your work changed practice, it, in a way, it's the aspiration of all statisticians. But I don't think, to be honest, beyond some of the tools and the method being used in practice, I wouldn't say it has really changed practice. So I have developed throughout some tools which have gone in to be widely used, but has it really changed practice? It's not that it got in the regulation or it's been massively adopted. So I think what I probably have done is change the way of thinking about some problems that other people have picked up, and it's like once removed. I think I've been not changing practice, but maybe once removed from that, and changed the way people were framing, let's say for measurement error problem, for the spatial things. For example, measurement error, it's so pervasive, these ideas which we developed with Wally, I picked up recently again, when I look at single cell data, which has a lot of technical noise. Again, we used, a combination of sort of gold standard with much larger data set and also use that in COVID, this idea of combine to sort of home down on a piece of kind of variability that you can actually get information on, or a piece of bias that you get information on from another source is a fundamental idea. And maybe, I've demonstrated that these ideas can be used in practice, but whether I've changed practice, I wouldn't go beyond that. And in terms of the policy side, during the last 2 years, I was technical director of this Turing RSS Health Data Lab, where we were really working within the UK Health Security Agency, and they had policy questions, and they were bringing some of them to the group, trying to get us to think a bit more medium term. They were doing very day-to-day, fast, at pace answer to government question, and we just our role was just to take a little step back from this example and see whether there were some more some objective that we could, some more fundamental sort of projects that we could develop, which would have a series, which could be repurposed and which have a series, answering a series of policy questions, and could be kind of reshaped and adapted as the situation evolved. And we did one, sort of core piece of work on how to debias some of the testing data by combining with what, as David was mentioning earlier, combining with randomized. So the idea of, observational and randomized, a small randomized, very well designed, combined with a big, large, and we actually implemented that so that UK HSA could have a sort of debias estimate into practice. Let's say that's the closest, I've been to policy, but this was still, again, once removed. It wasn't the decision aspect of policy as a decision framework, which on top of inference, and there's a decision that I've never been, in a decision framework.
This is
involvement.
Incredibly important work, like over the years, to change practice in an analytic field, say measurement error or data integration, or showing paths to integrate to diverse data sets. These are incredibly important. So thank you, David.
Yeah, I don't think it's not, I don't like tying anything to, a specific piece of work, a specific paper or anything like that, because one's just worked as part of a community in a particular area, which has then had an impact. For example, over COVID, it was quite interesting to see that, the main Pfizer randomized trial for their vaccine was designed on Bayesian principles with prior distributions and all this sort of stuff was in there. And I thought, well, that's quite cool. And I would have had some influence on that, I think. And then similarly, the real complex Bayesian modeling that's been using MCMC that's been going on throughout COVID. I thought, I've had some influence on that, even if it's not directly referred to. I think in terms of the policy, then the other work which I've been involved in, which is performance monitoring and working in public inquiries, has probably had most direct, in fact, in the way that, now if you go on to, you can go on a website and find out the mortality rates of your cardiac surgeon. You can find out the success rate of your orthopedic surgeon. They're all there. They're all drawn out using funnel plots. They're all done. They're being monitored using Q-sums and all that kind of stuff. And that's just taken for granted now. There's been a huge change in performance, analysis in healthcare. And I was just part of that, I suppose. But it was a really big change that's happened. And now, I don't know, I'm not so much interested in changing actual policies as the way in which they're communicated. So I do feel very strongly that, analysts in government who do a fantastic work and who tend to work behind the scenes and can't, by their contracts, directly interact with the media as personal individuals. However, they do produce the material which is increasingly becoming publicly available through, rather than just going into government as management information. The dashboards that reach such prominence during COVID are not going to go away. In fact, they should blossom. And this is almost direct communication between the analysts and the public and the media. I mean, there is some mediation, of course, but they're more and more in control of the language that's being used, the graphics, the explanations, interpretations, and things like that. How much interpretation to put on it. So it's a really exciting time. So, and that's regardless of the policy. So it's not like I don't feel I should be telling anyone what the policy is. It's not my job. And I have to keep on reminding others or saying that it is not the job of people like me to say what the policy should be. However, I do feel it's absolutely my job to say how the reasoning behind that policy should be communicated. As I said, just about the finest hour for myself and John Aston and Alex Freeman was when they were communicating the policy decision about the AstraZeneca vaccine and younger people because of the blood clots identified in the middle of last year. And we designed the graphics that were used live on television to explain this to the public, which is quite a big thing, showing the enormous difference in terms of the risk-benefit balance as you went down, as you got younger and younger. So for people like me, even at low prevalence of the virus, the benefits of the vaccine hugely outweighed any the harms. But when you got down under 30, it was really iffy. And so they went through all this explanation using our graphics and then said, and so we're not recommending that people under 30 should get the vaccine. And everyone said, thank you very much, and nodded their head. No complaints, no pushback, no accusations of U-turn, no accusations of what have you been exposing us to. Completely accepted by the media and the public. And I think that was very largely because of the communication and the information that was given and the way that the communicator, Jonathan Van Tam, Deputy Chief Medical Officer, highly respected and trusted figure, treated the audience with respect. He had our materials to go through and he went through them in great detail. And I thought, I thought, what's he doing? He's not going to try to explain all this, is he? And he did it. And people really appreciated being treated as intelligent adults, having a good narrative, strong visuals, trusted communicator telling a story, taking his time, coming to a strong conclusion about the basis for the policy decision, building up to it, and then saying, therefore, this is why we're doing it. And everyone just nodded their heads. So for me, that was a real case study on how, in terms of the collaboration between the policymakers and the communicators to the public and the technical, communicating the technical basis for that policy, how it can be done in a really trustworthy way, rather than these awful politicians getting up and just spouting out, we've decided something or other. Yes. What? Why? What's it? What? You're just making what appear to be somewhat arbitrary policies, which then they have to change and then get accused of doing U-turns. So that's my big feeling of, where we all should be working towards, I think, in terms of the delivery of the policy.
Yeah, I think that this is a very important point, and I think it has been a theme that has been coming up over and over again. Respect for your audience.
Yes, respect for your audience.
This is incredibly important, and work hard to achieve that.
Which means
and explain try to explain the uncertainty and that things change, and that it's good to change your decision where things change, rather than being accused of U-turn. It's ridiculous. The idea of you keep having to update. You do the best given where you are, and you update and so on, and you have to treat people not like idiots. And for example, I think governments really lost throughout Europe, lost the trust, part the trust of the population by first saying masks were not useful when they didn't have enough masks, and then changing and saying masks were useful when they had masks. Whether they should have said masks could be useful from first principle, but we don't have them. We're just getting stock as fast as possible, and then do your best with your scarves, and then when we'll have proper masks, we'll give them to you. Because by saying first masks are not useful, this was misinformation, and people lost trust in the communication. Don't you agree with that?
Absolutely. It's a real problem of politicians with expressing provisionality.
Yes.
They have to be absolutely sure of
Which
what
is
this is the right thing to
ridiculous.
do. Whereas in fact, of course, we know, especially back in March 2020, we didn't know what was the right thing to do. And so to say that, as I always follow John Krebs developed this. You say what you know, you say what you don't know, say what you're doing to find out. Say what people can do in the meantime,
exactly.
And say this, but we will come back to it and things will change.
Yes.
And if they say that right from the beginning,
then
you're sorted, but they will not do that.
No.
They cannot, politicians seem incapable of saying that because they work from conviction.
But our job is really to push that, because as statisticians, this is really the bread and butter of how we reason. And I think we're unique in trying to push that, with respect to other scientists. I think it's a unique role to keep pushing these ideas to improve basically, public understanding of reality.
I have certainly enjoyed this hour of brilliant conversation with two inspiring people in my life and for the profession. Coming to the close, my final question, looking into the future, what do you think are the most important qualities in a statistician or a biostatistician, and how do we teach our students? Any pearls of wisdom for the next gen? They're looking forward to hearing your advice. How do we put your passion into practice, into our current education system, and shape it up?
Well, I would say, I'm taking for granted that they would have a broad statistical culture. I think it's important to get exposed to broad ideas and have confidence in that background. But then I think they have to develop expertise in a subject area, in whatever subject area they are going to engage it, whether it's public health, whether it is biology, some part of biology and things. And they have to have passion to actually understand the subject area and be open to, so that they can open a meaningful dialogue and basically have the vision that, it's really a cooperation and of ideas, so that they translate their ideas so that the collaborators can understand, and then they can actually have a vision of a project which has, a sort of more abstract methodology component and delivery for the. So I think it needs to have a passion in the ideas, and also a passion in solving the question and understanding, not just a superficial understanding. And for some domain, it really is hard. So it's really an investment, and an intellectual investment of time. And you have to be able to have a listening mode and an active role. Because if you're just in a listening mode, it's very important, but you also have to be able sometimes to really suggest things and take hold, and don't let the collaboration run away with completely outside of, you have to somehow keep pushing towards a vision for a balanced collaboration and an aim. So I think, being able to be adaptive to listening and active and proposing and putting your vision across, so you need also good communication skill and the capacity to translate your technical tools into something that the collaborators will understand. And so you don't want them to end up with a good solution to the wrong problem. So you need to be, constantly engaging in dialogue, listening mode, active mode. So I would say broad statistical culture is important. It's no good to be too specialized, because often people kind of reinvent the wheel. So you have to pick up ideas from other areas that could be very useful in what you're trying to solve. So really have a broad statistical culture, quick on the uptake, interested and knowledgeable in the particular health field, and this can change over time. And then keeping sight of the purpose of the collaboration and of the range of things it can deliver. So you get a balance of objectives. You don't get you are solving the question, but you're also extracting some more generic understanding, which could be useful again, repurposed, and so on. So you want to keep, not be, influenced by the specific question, but keep nevertheless sort of in the back of your head that there is a broad perspective, and that's part of the development of your career, is to build this vision and this connection between the different areas, the different problems that you'll be experiencing. So you need to keep a little bit of always constant about the generic aspects. So it's quite it's a challenging game, because you need to understand the specific, but keep calling back on your culture and your principles. And it is back and forth, which I think is the quality of a good biostatistician, and to which how they endeavor with this balance. And maybe later I'll tell you how we could teach that, but maybe I'll let David.
Yeah, I agree. I do think people should do as much technical stuff as they can, so they feel confident in the methods that are being used, and so not be intimidated by somebody saying, "Oh, what about X?" They can actually know what that means. So I think that you want to do, and all those skills, computational skills, visualization skills, so all that necessary. But I think I agree with Sylvia. As we come up again and again, you've got to have sensitivity to the audience. There's an element of being a counsellor. Someone walks in, you say, "Well, why are you here today? Tell me about your problems." I always think there should be a box of tissues on the table between you, as
data tissues.
Exactly, data, as they explain their problems to you. But as Sylvia said, this isn't counselling in the sense of just reflecting back and let someone talk. In the end, you do have to be fairly directive as well. Having really tried to understand what the issues are, you should be directive. But again, as Sylvia said, you shouldn't be trying to just cram everything into your particular way of viewing things. You have to have sensitivity to what the problem demands, what level of sophistication is appropriate. And so I do think statistics is an enabling technology. It exists in order to help other people solve their problems. That's it. That's the reason it exists as a subject. And so that is, I think, an essential part, that sensitivity to other people's problems and really wanting to help them solve them, is the main training, apart from the technical side,
yes,
that specifically a biostatistician needs.
Yes. And then in terms of how do you develop, how do you help develop? I think you have to do it by example. You teach by example. And I think it's very important to be open about the problems you've encountered in the past, the mistakes you've done, for example, in collaboration, things you've missed. You've got to be very open and explain how you faced, this collaboration or this issue, and how you've solved them and have you've learned. I think this is only by example. It's not a formal teaching. And so, PhD students and postdocs, you have to keep talking to them about, see how they think about the problem, and then relate it to your experience about similar things, and give them opportunities to interact and point them in the right direction, and so on, and keep thinking their particular needs and their particular skills, how you can round it up. And I've recently have an experience of somebody who was is a very, very bright methodologist, but really wanted to write a piece of work which has like an impact, a biological impact. And we know it's such a different way of working when you've got these massive groups of say biologists, and how they drive a piece of work, and trying to be having basically done the whole analysis of the work, trying to drive the whole project into this kind of delivery piece, which are at the level of a Nature paper. That's such a learning experience, and it's such a frustrating experience when you are an up-and-coming young person, you really have to get support from your mentors and your peers to get you through that. But once you've done it once, wow, you've acquired, something really valuable for the rest of your life. But it does require, careful, careful example and careful support tailored to the new up-and-coming biostatisticians. But it's a joy to give that, I must say. So that's something I really enjoy, and I think most of us really do enjoy as well, because it's a pleasure to see how they develop, how the people that you nurture develop and progress their career and be so creative in tackling new problems. So yeah.
Yeah, I think really it's what Sylvia says. I mean, you have to do it by example. People have to just, be confronted with problems. So I think, working on consulting, small scale consulting is really valuable, because, you've learned on nice little rectangular data sets, beautifully collected, and then someone brings us stuff in and there's bits missing, it hasn't been, odd, it's only based on people having to walk in through the door, and you're suddenly confronted with all the horrors of real data, and I think that's very valuable. I also think it's valuable to, and in a way probably easier to do, is to get people to critique published or pre-printed papers. I always think you should be able to tear a paper apart in about 2 minutes. I think it should be the maximum to discuss. So I would do this as a competition. Yes. I would do it as a competition. Hand them out. Right, you've got 2 minutes. Find 4 things wrong with this study, and you start by giving them half an hour, and then 50 minutes, and then so you can do it in 30 seconds.
I'm hiding all my papers from you.
Yeah, no, you would pick some real rubbish. I mean, there's lots out there. So I think that would be a great exercise. Yes. I think actually, tearing apart papers should be a competitive sport.
Any last minute words as we come to the close?
Oh, I think we've said enough.
Yes, I think it's been really. I want to thank you, Bhramar, for suggesting this exercise, and I've really enjoyed preparing. It's challenging, to do such interviews the first time. Basically, I've done it on that level. David is probably much more used to interview, but I think I feel
yeah, but maybe we're too similar though.
No,
so maybe we worked together. We got very similarities. Maybe we should have found somebody who totally. Oh, I completely disagree with what they just said.
I'm glad you said we're similar, but I think we're still different enough. We are. So I think it worked. Thank you, David. I think it worked really well. The conversation and
It is, as I said, that this is your parting gift to me, and it was an incredible honor and privilege for this hour of enriched conversation. You taught us to embrace imperfection and complexity in data and life. And also really be feisty about our profession and tear each other apart, but also love each other. Support and incredible love for our profession. So on behalf of the entire worldwide statistical community and on behalf of statistical science, I just want to thank you. So
thank you, Bhramar. And I think we both probably want to take the opportunity to thank all the colleagues. We couldn't name them all.
I could list.
We could list so many. So I just want to take this opportunity to really thank all my co-authors and all the people I've had really the pleasure to grow with, grow my understanding.
I'd love to. List my co-authors, and not the papers with 100 authors, but just the ones and twos and threes, and vast numbers, all of whom have taught me something.
Yes, so I think it's a good opportunity to express that publicly. Thank you.
As I said, that you're incredible researchers, but wonderful human beings. Thank you for your presence in the community and your leadership.